Alright, let's use 2.9 and 2.8 in a real-world example to show that they're true. This is exactly what I'm looking for. If you're in group 5 or 6, I want you to go on Google or find an image that's appropriate for school that you can use to show that 2.8 and 2.9 support each other and work together. So we're going to start with 2.9, and that says if two lines are perpendicular to the same line, then they are parallel to each other. We're going to take this one step further, and we're going to show that if three lines are perpendicular to the same line, then they are parallel to each other. What I want to do here is look at this photo, and we have our line 1 here, we have our line 2 here, and we're going to use this concrete piece and say this is line 3. Now line 4 is going to be, I don't want to use blue, right here. Now, let's find a color that will stand out. Okay, line 1 is perpendicular to line 4. And as you can see, the diagram that we have here is starting to look, in the picture we're using, they're starting to look very similar to each other. Line 2, which I have here, is also perpendicular to line 4. And line 3 is also perpendicular to line 4. So right now I'm showing three lines are perpendicular to the same line. That means line 1, line 2, and line 3 are all parallel to each other. Let's write that up here. So we can see that line 1 is parallel to line 2, which is parallel to line 3 by theorem 2.9. Now let's go look at theorem 2.8 and see if we have something here. If theorem 2.8, if two lines are parallel to the same line, then they are parallel to each other. So let's look back here, and we're going to look at this right here. Change the color to something a little bit more. Let's go back to purple. So it's saying if two lines are parallel to the same line, then they are parallel to each other. Since line 1 and line 2 are parallel to line 3, so if line 1 is parallel to line 3 and line 2 is parallel to line 3, then so we have L1 and L3, L2 and L3 are parallel, then L1 is also parallel to line 2. That's theorem 2.8 and 2.9 quickly, easily, and I think this is a great real-world example. When I said you can start looking anywhere and start seeing this constantly, I wasn't kidding. Let's see, is there anything else in this picture? Just really quick, I want to, yeah. So if we were to look, let's go to green. Right here, if we focus in on this part, I have the railing here, and I have the walkway, and then I have the cross members. Each one of those is perpendicular to the walkway and the railing. Again, that's theorem 2.9. Some more examples for 2.9 in the photo would be simply, if you look at this house here, I'm going to zoom in on it for us, make it a little easier to see. Oh, didn't need that line there though. Alright, don't know why that's there. So, if we want to look at this house, look at the roof line for the second floor. You look at the roof line for the first floor. And then we can look at this little window. That line goes straight down. Wow, did the first two great, but not this one. Try it one more time. So, with these lines, I'm trying to see if, I'm going to call it R1 for roof line 1 and R2 are parallel. And I'm going to do that using the three lines I have here. So, R3 and R2 are perpendicular. R1 and R3 are perpendicular. And since theorem 2.9 says if two lines are perpendicular to the same line, they are parallel to each other. So I can now say that R1 is parallel to R2. See if we find something else in this photo, because it really is endless possibilities. Well, not literally endless, but there are quite a few. Here's a go back towards 2.1. This is our 1.7 actually. This is our vertical angle theorem. We can see this line and this line intersect each other. So I know that this angle that I'm coloring in teal and this angle are congruent to each other. And the angles that I'm about to color in orange are congruent to each other by the vertical angles theorem. Let's look at this piece. Here's one line, here's another line. Let's call these B1 because there's a bird on it, and B2 because there's a bird on it. We're going to see if we can show that they're parallel. Oh, this would be line B3. Let's make this a little smaller because we're having a hard time. Okay, so if B1 and B3 are perpendicular and B2 and B3 are perpendicular, then we can say that B1 is parallel to B2. I'm not going to keep going through this photo. We've done plenty of examples with it, but I really think this is a great example of what I want to see during your presentation in class. When you're to find a photo, you can do, just take a Google downtown Tampa and all of those buildings. There's going to be so many examples that you can use theorem 2.9 and 2.8 to show that lines of the buildings are parallel, sidewalks are parallel. Those are all very easy things to start with. I would definitely keep this in mind when you are doing your presentation for the class.